Hello friends, my name is Rohit and I am teaching Quant and DI to the CAT students for the past 8 years. Today we will discuss modulus inequalities. So before the start of the topic, let us have a quick overview of the things that we are going to discuss in this session. We will discuss the concept of modulus inequality, then there will be problems based on the modulus inequality, and after that there will be certain practice questions as well as their answers. So let us start our session. Now we will discuss the modulus inequalities. Let us have an inequality mod x less than 3. Here we can see that x equal to 3.1 will not satisfy this inequality, or you can also see that x equal to minus 3.1 is also not a solution of this inequality. But if you put x is equal to 2.9, yes, it is a solution of this inequality, as well as x equals to minus 2.9 is also a solution to this inequality. So from here I can say that all the points between these 2 points are the solution set of this inequality. So we can generalize this result. We can see that if mod x is less than a, then our x lies in between minus a and a. Further, if we take mod x greater than 3, we can see that x equal to 2.9 or minus 2.9, they are not the solution set, but x is equal to 3.1, 4, 5, all these points are the solutions to this inequality, as well as x is equal to minus 3.1, minus 4, minus 5, all these are also the solution of the inequality mod x greater than 3. So that means I can say that if mod x is greater than a, then the solution of this inequality will be either x greater than a or x less than minus a. Now these two are the basic results that we are going to use in the questions in next slides. Also keep one thing in mind, that for modulus function, mod x is equal to x if x is positive, and it is equal to minus x if x is negative. So this one is the second result that we will use in the questions. Now let us discuss this concept in the next question. Here we have mod x minus 7 less than 8. Now we know that mod x less than a means that our x lies in between minus a and a. If I use this concept here, I can take this number as my x. So just compare the number inside the modulus with the x here. So from here I can write it as my x minus 7 lies in between 8 as well as minus 8. Now solution means the value of x, means I have to eliminate 7 from the middle part of this inequality. For that we will add 7 throughout the inequality. So the solution will be minus 1 less than x less than 15. So this is a solution to the given inequality. Here we have mod of 3x plus 2 less than 5. Now again I will use the result that if mod x is less than a, that means x lies in between minus a and a. Now for that, if I compare the term inside the modulus in both the inequalities, so I can say that I have to replace this x by 3x plus 2 in the inequality part. So the solution to mod of 3x plus 2 less than 5 will be minus 5 less than 3x plus 2 less than 5. Now I want only x in the middle part. For that, first of all I will remove 2, I will subtract 2 from throughout the inequality. So the result will be minus 7 less than 3x less than 3. Now I will divide the whole inequality by 3. Now just remember one thing, that whenever you are multiplying or dividing on both sides of inequality by a number, then the result or the sign of inequality will remain unchanged if you multiply or divide by a positive number, but if you are multiplying or dividing by a negative number, the result or the sign of inequality will change. Now here I am going to divide the whole inequality by 3, which is a positive number, so it will not affect the sign of the inequality. So the final result will be minus 7 by 3 less than x less than 1. So this is the solution of the given inequality. I hope you all have got the point. Now come to the next question. This one is a little bit trickier. We have to solve this inequality where x is not equal to plus minus 2. Now, for its solution, I have mod of x minus 1 divided by mod of x minus 2 greater than or equal to 0. Now, what I will do here is I will take mod x equal to some other variable, say y. So my inequality will change to y minus 1 upon y minus 2 greater than or equal to 0. Now to find a solution set of this inequality, I will plot the number line and plot the points. So the critical points are 1 and 2. Now this part of the number line will give you the positive inequalities, this one will give you the negative, and this one will give you the positive inequalities again. Now from here I can say that the solution is either less than 1 or it is greater than 2. So that means y is less than or equal to 1. Now why it is less than or equal to 1? Because the inequality says that it is greater than or equal to 0, or it is y greater than 2. Now what was y here? Y was actually mod of x. Now in the second part of the solution I will write y as mod of x. So mod x is less than or equal to 1 or mod x is greater than 2. Now from here I can write it as x lies in between minus 1 and 1. Now here I can write it as either x is less than minus 2 or it is greater than 2. Now if I combine the both parts, what we will get is minus infinity, x lies in between minus infinity to minus 2 union 2 to infinity, or we have x belongs to minus 1 to 1 with close bracket union minus infinity to minus 2 union 2 to infinity. So this is our solution set to the given inequality. I hope you all have got the concept. Now again in this question we have mod of x plus 3 plus x upon x plus 2 greater than 1. Now to solve this inequality, first of all we will transpose 1 from right side to the left hand side. So we have mod of x plus 3 plus x upon x plus 2 minus 1 greater than 0, or mod of x plus 3 plus x minus 2 upon x plus 2 greater than 0. From here we can write it as mod of x plus 3 minus 2 upon x plus 2 greater than 0. Now we know that mod x is equal to x if x is positive, and it is equal to minus x if x is negative. Now we will make use of this concept. So we have two cases here. Case 1, if this term x plus 3, first case, if x plus 3 is greater than or equal to 0, or if x is greater than or equal to minus 3. Now in this case mod x plus 3 will be equal to x plus 3 from here. So that means I can write the given expression as, or I can write this thing as x plus 3 minus 2 upon x plus 2 greater than 0, or it is equal to x plus 1 over x plus 2 greater than 0. Now since the right hand side is 0 and the coefficient of x are positive in both numerator and denominator, so the solution set to this inequality will be, just plot the critical points, minus 2 from the denominator and minus 1 from the numerator. This region is for the positive inequalities, this one is for negative, and this one is for positive again. So that means the solution set will be x belongs to minus infinity to minus 2 union minus 1 to infinity. But here we have x greater than or equal to minus 3. That means we cannot write it as minus infinity to minus 2, but actually x is greater than or equal to minus 3. That means the solution set will be x belongs to minus 3. Now x is greater than or equal to minus 3, so minus 3 will be included in the solution. So minus 3 to minus 2 union minus 1 to infinity. Now in the second case, if x plus 3 is less than 0 or if x is less than minus 3. Now in this part, mod of x plus 3 will be equal to minus of x plus 3. So our inequality mod of x plus 3 minus 2 upon x plus 2 greater than 0 will be equal to minus of x plus 3 minus 2 upon x plus 2 greater than 0, or it is equal to minus x minus 5 upon x plus 2 greater than 0. Now, although the right hand side of the inequality is 0, but the coefficient of x in the numerator on the left hand side is negative. So to make that coefficient positive, I will multiply both sides of the inequality by minus 1. So the final result is x plus 5 over x plus 2 less than 0. Now if we plot these 2 points on the number line, the critical points are minus 5 and minus 2. And this part is for the positive inequalities, this one is for negative, and this one is for positive inequalities. Since our inequality is negative, so the solution set will be x belongs to minus 5 to minus 2. But x is given to be less than minus 3, so we have the solution as x belongs to minus 5 to minus 3. Now if we combine these two results, the final result comes out to be x belongs to minus 5 to minus 3, then minus 3 to minus 2. That means minus 5 to minus 2 union minus 1 to infinity. So this is the solution of the given inequality. So here are certain practice questions which you should do by using the concepts which we have just discussed in the previous slides. So here are the first two questions. The next two questions, question number 5, and here are the answers. To learn such more concepts, you can also subscribe to our channel on YouTube, hitbullseye.com. Thank you very much.